Greetings, Earthlings. Today we are going to be talking about adding fractions using factor trees and multiplying by 1. And I'll explain what that means in a second. So, usually when you add fractions, or the way you may have been taught to add fractions, is to look for the least common denominator by finding the least common multiple of the two denominators and doing some multiplication mumbo jumbo to try to get them to match up and then adding them. But I think that's a lot of work, and I think my way might be a little bit easier. Well, you can judge for yourself after you try it. So let's get started. So the first thing I'm going to do is show you this technique where you multiply by 1. So we have our fractions here, and we cannot add them yet. And we cannot add them because the denominators are different. You know, when the denominators are different, it's almost like adding different units. Like, it wouldn't make sense to add inches to meters. It only makes sense to add inches to inches. So this is 1/3 and this is 2/5. And those are kind of almost like different units. So it doesn't make sense to add them as they are. So what we're going to do is we have to find a way to make that 5 and that 3 a different number that happens to be the same. And we have to rewrite the fractions so that it's the same fraction but has a different appearance. And the way we do that is we multiply the fractions by 1. And you can't multiply a fraction by any other number besides 1, because if you multiply it by another number, it will become a different number. So if we want the value of the fraction to be the same, we have to multiply it by 1. But we're not going to write it as a conventional 1 like we have written right here. What we're going to do is we're going to multiply it by a number divided by itself, because a number divided by itself is the same thing as 1. And the number that we're going to pick is the denominator of the other fraction. So we're going to multiply 2/5 times 3/3. And 3/3 is, of course, the same thing as 1. And then we'll do the same thing over here. And we're going to use the denominator of the other fraction. 5/5. So now we can multiply them. So 5 times 1 is 5. 3 times 5, or 5 times 3 is 15. And we have 2 times 3 is 6. And 5 times 3 is 15. And look at that! The denominators are the same now. So now we can add them. Okay, let's see. 15, so 5 plus 6 is 11. And we get 11/15. Here's an example that's a bit more complicated. Here's an example with fractions that should probably be simplified before we go any further. Now, I could just go straight up multiply by 1, and then I'll have 6/6 here, and 12/12 here, but then I'm going to be dealing with some big numbers that I don't really want to be dealing with. Like, I don't really want to be dealing with 6 times 12. You know, I want to be dealing with small, easy numbers. So let's simplify this first using the factor trees. So you can go back and watch the factor tree other videos if you want a refresher. So we start with a factor tree for each of the numbers. Oh, so 3 is an acorn factor tree, a tiny baby one, a little tiny baby tree, because it's already a prime number. So it is a leaf in and of itself. 2 is the same way. All right, let's do 12. Well, the first thing I can think of that multiplies to get 12 is 4 times 3, and 3 is a prime number, but 4 is not, so that's 2 times 2. Those are prime numbers. And then we could do 6. and that's 3 times 2. All right, so our factor trees are all done, so we can rewrite the fractions now. So 3, well, that could just be rewritten as 3 because it's already a prime number, but 12 can be rewritten as 2 times 2 times 3. And 2 over 6 is, well, it's just 2 over top, and 3 times 2. And then we look for the partners. We match them up like eharmony.com. And then we scratch. Well, I got nothing on the top, so I rewrite that as 1. I got nothing at the top, so I rewrite that top as 1. And at the bottom, I have 2 times 2 is 4, and then just 3. Okay, so they're all simplified, so now we can do our multiplying by 1. And the denominator of the other guy is 4. And the denominator of the other guy is 3. So 3 times 1 is 3, and 3 times 4 is 12. Oh look, we have the same thing that we had over here. It's just by coincidence that we got 12 back out again. And you might be thinking, but Sophia, wouldn't it have just been easier to multiply 2 times 2 over here and make that 12 to get the least common denominator? Well, that probably would have been easier. However, sometimes it's not always obvious what we should multiply it by to get the least common denominator. Sometimes, you can't always figure out what you need to multiply it by. So this is a way to figure it out when those shortcuts are not always obvious. So 1 times 4 is 4, 3 times 4 is 12. Oh look, the denominators are the same now. So now we can add across the top. And we get 7 over 12. And we only add across the top. We do not add across the bottoms. Another example where we need to do a little bit of simplification first before we can get started. Alright, so we're going to do our 4 factor trees. So 10, I'll do them sideways today. It's 2 and 5. 60. And a good thing to remember about 60 is to think of minutes. Okay, so I know half a minute is 30 seconds. And half of 30 seconds is 15 seconds. And then 15 is 3 and 2. Oh, sorry, 3 and 5. Can do 16 and 48 over here as well. 16 is 4 times 4. 2, 2, 2, and 2. Looks like I'm gonna run out of room, but I'll just shrink it down. Gotta prune our factor trees. Ooh, I forgot to circle my leaves. It's always good to circle your leaves. That way you don't get your leaves confused with your branches. Okay, 48, that's 12 times 4. Well, neither of those are prime numbers. Oh my gosh, my factor trees are so disorganized today. They're just growing all over the place. Like they got too much fertilizer. Too much nitrogen in the soil. Alright, so now we can rewrite the fractions. So 10 is 2 and 5 over top of 60, which was 2 times 2 times 3 times 5. And then 16 over 48. So 16 was 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 over top of 2 times 2 times 2 times 2 times 3. Okay, look for the partners, match them up. And it's these poor kids here. They're the kids in class that don't have anybody to do their group project you're with. Well, that brings back some unpleasant memories for school for me. And we have a lonesome 2 and a 3, so we get 1 at the top. 2 times 3 is 6, plus, well, everything on the top over here is used up, and just a 3 is left. Okay, so now we can do our multiplying by 1. So this will be 6, this will be 6, this will be 3, this will be 3, 1 times 3 is 3, 3 times 6 is 18, plus 1 times 6, 6, 3 times 6 is 18, and I get 9 over top of 18. Well, 9 over 18, that's not very simplified. You know what we gotta do? We gotta do some factor trees again and simplify that. So we'll make some tiny factor trees over here. So 9 is 3 times 3. So we can rewrite the top of this fraction as 3 times 3. And then 18 is 2 times 9, which is 3 times 3. It escaped. And so we get 2 times 3 times 3. Look for the partners. And then we got nothing left on top, so that'll become 1. And only thing we have at the bottom is a 2. So at the end of the day, we are left with 1/2. And we're all done. Look at that. Wait a minute. This one's a little bit different. That's not an addition sign. That's a minus sign. But you want to know a secret? So all the tricks and stuff that we can use for adding fractions, we can also use for subtracting fractions. Okay, let's start off with our factor trees. Make these nice and simplified. 2 is an acorn factor tree. 4, well, it's a tiny factor tree. It's only got 2 guys in it. It's like a little tiny sapling. 3 is an acorn. 9 is also kind of a little tiny sapling factor tree. Rewrite them. 2 over 2 times 2. Match them up. Scratch. 3 over 3 times 3. Scratch those puppies off. Alright, so we get 1/2. I made a mistake. 2 over top of 2 times 2, because that's the same as 2/4, minus 3 over top of 3 times 3. And we can match it up and scratch. And then what we got left is 1/2 minus 1/3. Okay, we are not at all ready to subtract because the denominators are different. So we got to do our multiplying by 1. So 3 over 3 for this guy, and 2 over 2 for this guy. I'm using lots of 3's and 2's today. So what we got left is 3 over 6 minus 2 over 6. And now we can subtract the tops and we get 1/6. And we're all done. Look at that. All right, let's summarize the steps of adding fractions using my method that I think is a little bit easier. Step number 1. We are going to simplify both fractions using the method of your choice. I personally prefer the factor tree method. Step number 2, we are going to multiply the top and the bottom of each fraction by the denominator of the other fraction in order to make the denominators the same. So basically we are going to multiply each fraction by 1. Next, we are going to add the tops of the fractions together, or subtract if we're doing subtraction. We are only going to do the tops and we are not going to do the bottoms. 4, if we need to, we will simplify the fractions again. And those are all the steps. Look at that. We know how to add fractions now. Isn't that fun?